In this last introductory material, we're going to take a look at what's inside of the computer. We're going to provide an introduction here to the organization and internal workings of the computer. Generally, all computers are going to have the same type of structure and the same devices and components. So, whatever we give here, you can primarily think of them as just about like any type of PC, Macintosh, laptop, whatever you've got, it's going to match the components. One of the most important features of how a computer functions is by the amount of memory it has. We need to review the terms associated with the measures for the amount of memory inside of a PC. Recall from a previous discussion we used the term bit or binary digit that can have a value of 0 or 1. A byte is defined as 8 bits. A nibble is half a byte or 4 bits. A word is 2 bytes or 16 bits. The display is intended to show the relative size of these units. Of course, they could all be composed of any combination of zeros and ones. Looking at the units of measure here, a kilobyte is 2 to the 10th bytes, which is 1024 bytes. The abbreviation K is often used to represent kilobytes. For example, some of the older floppy disks held 356K of data. A megabyte, or a meg as it was called, is 2 to the 20th bytes. That's a little over a million bytes, or exactly 1,048,576 bytes. Moving up the scale in size to a gigabit, or 2 to the 30th bytes, or over a billion, and a terabyte, which is 2 to the 40th bytes, or over 1 trillion. As an example of how these terms are used, suppose that a given computer has 16 megabytes of memory. That would be 16 times 10 to the 20th, or 2 to the 4th times 2 to the 20th, which is 2 to the 24th. Therefore, 16 megabytes is 2 to the 24th bytes. So you had to draw on a little bit of your algebraic skills there to see how the exponents are added. Two types of memory are commonly used in microcomputers, RAM and ROM. RAM, which stands for random access memory, is sometimes called your read-write memory. ROM, which stands for read-only memory. Where RAM is used by the computer for temporary storage of programs when it's running, this data is lost when the computer is turned off. For this reason, RAM is sometimes called volatile memory. ROM contains programs and information essential to operation of the computer. The information in ROM is permanent. It's typically thought of as being burned onto a chip. It cannot be changed by the user and is not lost when the power is turned off. Therefore, it's considered to be non-volatile memory. Looking at the internal organization of a computer, these blocks and bus diagrams give you an idea of how the components talk to each other. The internal working of every computer can be broken down into three parts: the CPU, the central processing unit, memory, and I/O, the input-output devices. The function of the CPU is to execute processes of the information stored in memory. The function of the I/O devices, such as a keyboard or a video monitor, is to provide a means for communicating with the CPU. The CPU is connected to memory and I/O through strips of wire that we call the bus. The bus inside a computer carries information from place to place, just as a bus carries people from place to place. In every computer, there are three types of buses: an address bus, a data bus, and a control bus. For a device like memory or I/O to be recognized by the CPU, it must be assigned an address. The address assigned to a given device must be unique. No two devices are allowed to have the same address. The CPU puts the address, in binary of course, on the address bus, and the decoding circuit finds the device. Then the CPU uses the data bus either to get the data from the device or send data to it. The control buses are used to provide read or write signals to the device to indicate if the CPU is asking for information or sending information. Of the three buses, the address bus and data bus determine the capability of a given CPU.